In this video, we're going to tackle Fal1out. So Fal1out is basically the second CTF in this Ethernaut series by OpenZeppelin. So let's continue and look at the code. So here the code, we see that this Fal1out contract is using Solidity version 0.6. These are an older version of Solidity. Then here we are importing OpenZeppelin's safemath.sol from the math contract. And this is just to help in solving overflows and underflows which were vulnerable in the earlier versions of Solidity 0.6, as you can see here. So the contract's name is Fal1out, and here we have using safemath for Unit 256. This is just applying the safemath.sol to check for overflows and underflows. Then you have a mapping here. This mapping maps addresses to Unit 256. And it's called allocations. Then we have this address payable, public, owner. Then this is the juicy part here, the constructor. So let me give you a little bit of history. So in the earlier versions of Solidity, that is Solidity 0.7 earlier, the constructor was basically formed by using the contract's name, as you can see here, Fal1out, by creating a function which had the same name as the contract's name. So if you had a function that had the same name as the contract's name, then that will be your constructor. So basically, this is the way that earlier versions of Solidity 0.7 and earlier on used to make the constructors. So as you can see here, we have this constructor comment here. We have this function constructor, which is public and payable, and it sets the owner to the message.sender. This means that it sets the owner to whoever calls the contract. Then here we have the allocations of the owner to message value. So whatever they send with that call is becomes their allocation. Then here we have a modifier, which is the only owner, which requires that the message.sender equals the owner. So in which function it will be applied, it will require that this is satisfied. Then this is just to continue running the rest of the code in that particular function where it will be used. Then here we have a function called allocate, and it's a public payable function which sets the message.sender allocations to whatever amount they send here. Then you have the function send allocation, which takes parameter, an address, payable, allocator. Then it requires that the allocations of the allocator be greater than 0. Then this can send the funds of the allocator to their address. And then the next function is collect allocations. So this takes the balance of this contract and transfers it to the message.sender, whomever called this function here. Then on this last function, it's allocator balance, and it takes an address. Then it's just to view the funds that the whomever calls this, whomever we pass here as a parameter has in terms of allocation. So what we'll do, we'll grab this whole code here, then we'll paste it in our VS Code, and we'll use Foundry to solve this CTF. So let's get started. So I'll just go into my virtual machine and I'll log in, because Foundry can be used in Linux or WSL environments. So here I already have our function here pasted here, and this safemath.sol is only applicable to versions earlier than 6.8. So what you'll do in order to compile this and so that it works, what we'll do, we'll go back here and search for safemath. So if you search for safemath, you'll get the contract at OpenZeppelin's GitHub repository. So what we'll do here, just grab this entire code, come here and copy this, then you include it in your files here. So you can just create a directory here. I called it contracts, then I pasted this here, as you can see it right here. it is the safe math utility here, the library here. So I'll just go back to this now. This is now compilable because now we have this safe math here. We're now importing it as opposed to how it was shown in the Ethernaut's OpenZeppelin's website. So what we'll do here, we'll just quickly go here into our scripts, and I'll create our script here. I'll call it Fal1out solution .s.sol. .s is just to denote that this is a script. It's the canonical way of writing scripts extensions. So then let's just, what I'll do, I'll come back to our earlier on solution here. I'll grab its entirety. If you don't know how we solved this, you can just look back to the previous video. So I've just copied that and I'll paste it here so that you can use that as a template. I'll paste it here, then I'll edit a few things here. I'll get rid of all this execution inside here until here. Let me delete that. So then I'll also delete this. Then we'll go back and get our instance. So I'll go back here, then I'll click get new instance. Then we'll confirm the transaction, then get our instance and use it to run that exploit. I'll confirm the transaction. Then once this is done, we'll open our developer console and just grab our instance for this particular level that we'll use to reference this contract in order to interact with it in Foundry. So let's do that. And as you can see here, it's done. The transaction is confirmed. Now if you just do Ctrl+Shift+I so that you can use the developer console to get the instance. So here it is, and here is our instance address right here. Let's just grab that in its entirety. Then come back here and let's paste it inside there. Okay, we have it there. I'll just reformat this. I'll also change the names here. So first thing here, what we're importing is not fallback, but is Fal1out. So let me first change that. Fal1out, that's what we are importing right there. Then everything here looks okay. Then I'll just rename this to, let me call it Fal1out, and this should be Fal1out solution. We're inheriting the script from this forge, that's okay. Here I'll also change this to Fal1out, the name of the contract, and also change this one Fal1out, and at this point we should be good to go. Then we have this run function here. This is where Foundry injects its activities right here. So we have em.broadcast, start broadcast to start our broadcast. So what I'll do first, let's get back to, let's close this and I'll open this Fal1out, the contract that we are interacting with. So as you had said earlier, this function name here, this Fal1out should be our constructor, but the vulnerability here is that the people who are writing this code wrote fal with 1 then out instead of matching the Fal1out name. That means that if you mismatch this function name with the contract name in the earlier versions of Solidity, it means that this is no longer constructor, but it now becomes a normal callable function that anybody can call, and it's also given here, assigned here as a public function. So this mismatch here is our exploit because it doesn't match the name of the contract, meaning it's no longer a constructor. And now this means that if we call this function, when the contract is, when we call this function here, it will set us to the message dot the owner, because we will be the message dot sender. So let's go and do that. So I'll just do, before we call that function, I'd like to see who is the initial owner, and the initial owner should be the address 0, because nobody will be sent as the owner of the contract when it will be deployed. So I'll just call Fal1out.owner. Okay, let me first do this. I'll say initial owner. Then I'll just call Fal1out.owner. Okay, that way. Then the next thing we'll do, we'll do Fal1out dot, then we'll call this Fal1out function name here. Then I'll now check to see who is now the new owner, and the new owner should be our wallet address, because we'll now be the ones who have set this. So I'll just hit tab. Yeah, now we have the initial owner, which should be address 0 if we are right. Then we call the Fal1out function, and this makes us the owner. Then now the new owner will be our address. So this is done. Let's do control save. This should turn to X in a short while. Okay, there it is. Then here in our console, in our terminal here, let me just clear this. Then what I'll do source.env to get our environment variables in this particular terminal, because it's a new terminal. If you're not sure how to create your .env, you can check out our first video in this series. So after that is done, what I'll do, I'll just run this script right here. So to run that, I'll do forge script. Then I'll specify the path of the particular script that you're working with. So that will be Fal1out solution.s.sol. So I guess that's okay. I'll just tab that. Then we'll write our RPC URL. We are broadcasting it to the Sepolia testnet, so that will just be okay. Let me escape that. I just hit tab. Okay, here it's just the same thing, but let me just write Sepolia URL. This is how it is saved in my .env. Then next we'll embed here the private key. This is the flag for private key. Then I'll just reference it. The variable name is private_key. Then I'll do a dry run before broadcasting it to the Sepolia testnet. So let's just run this. I guess everything checks out. Let's first run this and see. We'll give it time to load, then we'll come back when it's done. So here we're seeing that we have an error, found incompatible versions. So let's fix that real quick. Here it only works with the Solidity versions 0.8 onwards, and let's check our Fal1out.sol 0.6 onwards. So what I'll do here, let me just change this to 0.8. No, not that way. 0.8 and Control S, and let's rerun. First, let me come here and just do a clear. Then let's run that command and see if that works. Okay, we have this issue here in safe math. So I guess what we'll do here, let me just change both of them to 0.6. Control save that. Then let me also change this one to 0.6 so that we have the same versions all across. And again, do clear. Let's cross our fingers and hope this works out. Okay, this was successful, as you can see here. And yeah, we're getting all the nice things that we wanted. So let me scroll so that you can see here. We have the gas price over there, chain ID. Then here is where we have the logs. Let me scroll up a little bit. So as you can see here, the initial owner is address 0, as you had predicted, because there was nobody set when this function was being deployed. Then when you call the Fal1out function, we are now set to the new owner, because this is our wallet address, and we can confirm that by looking into MetaMask here. As you can see here, our address starts with 0x233, and that is the same address we have here, 0x233. So what we'll do, we'll just broadcast this so that it is broadcasted to the Fal1out testnet. Then we'll have solved this. So I'll just add the -- broadcast, tac broadcast. Then let's run that. So the first command that we ran without the tac broadcast was just to simulate the transaction, but when you add this broadcast flag, it will now run the real transaction. So that is what we have here. You can see it's broadcasting to the Fal1out testnet, waiting for pending transactions. So we'll wait for this to finish, and it's done. So I'll just go back here, and what I'll do, I'll click submit instance here, because we're done with this challenge at this point. You should see a pop-up here, and I'll click confirm. So when this transaction is mined, we should see here the console that we are done with this level. And that was it about this Fal1out CTF challenge from Ethernaut. So the thing about this was just trying to reference what happened in history, where a particular organization called Dynamic Pyramids was transforming and changing their name to Rubixi. And you can see here we are done. So as I was saying, and what happened was the contract's name were called Dynamic Pyramids, and also the constructors were also called Dynamic Pyramids. But when they changed to Rubixi, they renamed their contracts to Rubixi and left their constructors' names as Dynamic Pyramids. And this enabled attackers to exploit the constructor's name, which was now no longer the constructor, but just a normal callable function, and gain ownership of their contracts, and obviously drain funds from their contracts. So that was it about this level. And as you can see, we are done. Well, in the next video, we'll proceed to the next level. So yeah, cheers. I'll see you in the next video.